Okay, good evening everyone. I'm Dr. Vimala Roselin. I have completed MC and PhD and I am working as assistant professor at the Jayanti College. Now I'm going to explain about the Q. So Q is an non-linear data structure, sorry, linear data structures, and Q is an ordered collection of data items. So here the data in this data structure, uh, Q, especially in Q, two different points, end points are there. One is in front and rear. So we can delete the elements in the front position and we can insert the element in the rear position. So first element to be inserted in the queue is the first element to be removed. So that it is called as a first in first out method FIFO. And applications of queue. So where we are applying the queues, queue is widely used the waiting list, the single shared resources like a printer or a disk and CPUs. And one more thing, it is transfer the data and transfer the data and for example the pipes and file IO. And queue is used in the buffers in the most of applications like MP3 and CD players, and queues are used to maintain the playlist in the media player. Queues are also used in the operating systems for handling the input interrupts. And in the queue, there are many operations will be there. First one is an insert in an element into the queue or delete the element from the queue and checking the status whether the queue is empty or not, and checking the status whether the queue is full or not, and displaying the elements in the queue. These are the operations available in the queue. First, we are going to see about the insertion in the queue. So here the algorithm is given. Before we inserting the element in the rear, so first we need to check whether the queue has been space to add the element or not. So queue is empty or not, we need to check. So if the rear equal to maximum minus 1 means that will be overflow, go to the end, or otherwise we can add the element. So when you are adding the element, the rear value will be incremented by 1 because all the elements are inserted in the rear position only. So in the queue of rear equal to item means the item will be added in the linked list. So in the list, two values will be there, node and data. So to the pointer points the next pointer position. So in the data position, an item we can add. So in the rear point, if you are adding the value, that will be stored in the queue only. So how to check whether it is overflow or not? So for example, here when you are while inserting the element in the queue, so here for the example I given queue is some values they given in the queue. So this is a DQ, delete the queue in the front side, and NQ we are inserting the element in the rear positions. So when we try to insert the element in the rear position, but already in the queue list will be there. Some of the elements, if say, it will check whether it is empty or not. So here the no one node is empty, so we cannot insert the element. So it is called as a queue overflow. So likewise, queue is an underflow also will be there. Suppose in a queue list element are not there, that is an empty means we cannot delete a element in the front side. So that is called as a queue. Queue is underflow. So first we need to whether either we have to insert element or delete element. First we need to check whether the queue is empty or not. So if it is queue is full means we cannot add the element, or if empty the queue is empty means we cannot delete the element in the list. So these are the two operations. So very important in the queue. So in the queue also two very important terms are there, that is like DQ or NQ. DQ means deleting queue and NQ means inserting the element in the queue. Okay, another priority queue also will be there and circular queue also will be there in the queue. So these are the